Bismillahirrahmanirrahim. Assalamu alaikum. Let us revise that if we are given a non-homogeneous higher order ordinary differential equation of the form 1, then its general solution y is equal to yc plus yp. Yc is the complementary function, and in the previous lecture we have studied 3 different cases to find the value of yc. Yp is called the particular integral, and its value depends on the value of g of x. It means that for different values of g of x, we have different values of yp. So in this lecture, we shall study different cases to find the value of yp with the method of undetermined coefficients. Let us start from case number 1. If g of x is equal to e power ax, a is any real number, we shall put yp is equal to a e power ax in the given question. And then we shall simplify to obtain the value of a. Once we get the value of a, we shall put the value of a here, and that will be our required solution. If g of x is equal to b e power x, b is any real number, again we shall use the same substitution. Yp will be equal to a e power ax. Let us see an example. If g of x is equal to e power 3x, then put yp is equal to a e power 3x. If g of x is equal to 2 e power 3x, use the same substitution. If g of x is equal to 3 e power 3x, 4 e power 3x, 5 e power 3x, in all cases we shall put yp is equal to a e power 3x. Now this note is important. If there is a common term in yc and this yp, then yp should be multiplied with x. In that case, we shall put yp is equal to ax e power x. And if there is again a common term ax e power ax in yc, we shall put yp is equal to ax square e power x, and so on. Let us solve question number 1. Equation 2 can also be written as d square plus 3d plus 2 into y is equal to 24 e power 2x. Now, the first thing is to obtain the value of yc, for which we need the auxiliary equation. So the auxiliary equation is d square plus 3d plus 2 equal to 0. And now if we factorize this, we get d plus 1 into d plus 2 is equal to 0. So we have two distinct roots, d is equal to minus 1 and d is equal to minus 2. So the complementary function yc is c1 e power minus x plus c2 e power minus 2x. Now the next task is to find yp. Now yp, according to case number 1, is equal to a e power 2x. Let us say this is equation number 3. Now we shall substitute the value of y in equation number 2, but from here we obtain the value of y dash, which is equal to 2a e power 2x, and the value of y double dash, which is equal to 4a e power 2x. So substitution of these values in equation number 2 implies that y double dash is 4a e power 2x plus 3 y dash is 2a e power 2x and plus 2, the value of y is a e power 2x, which is equal to 24 e power 2x. If we simplify this, we get 4, 3 2s are 6. So this is 10, 10 plus 2 is 12. So we get 12a e power 2x is equal to 24 e power 2x. Let us compare the coefficient of e power 2x on both sides. So by comparing the coefficients, we have 12a is equal to 24. From here we get that a is equal to 2. So we will put a is equal to 2 in equation number 3. So therefore 3 becomes yp is equal to 2 e power 2x. So the general solution of this question is y, which is equal to yc plus yp. Putting values, we have y is equal to yc, which is c1 e power minus x plus c2 e power minus 2x plus yp. The value of yp is 2 e power 2x, and that is the required solution for this problem. Now look at one thing. In the value of yp and in yc, there is no common term. You can see yp is e power 2x. There is no e power 2x in yc. So that is why we don't multiply this with x. Case number 2. If g of x is equal to b sine x or g of x is equal to b cos ax. A and b are any real numbers, they may be equal to 1. In both of these cases, we shall put yp is equal to a cos ax plus b sine ax. For example, if g of x is equal to sine 4x, or 2 sine 4x, or 3 sine 4x, and so on, or g of x is equal to cos 4x, or 2 cos 4x, and so on, we shall put yp is equal to a cos 4x plus b sine 4x. Here I will revise that if there is a common term in yp and yc, we shall multiply yp with x. And if again we can see a common term, we shall multiply with another x, and so on, so that there will be no common term in yp and yc. And then we shall continue our solution. Question 2. To solve equation 1, the first task is to find yc, which is equal to c1 e power minus x plus c2 e power minus 2x. We have obtained this value in question number 1. And according to case number 2, yp is equal to a cos x plus b sin x. And from here we can get the value of y dash, which is equal to minus a sin x plus b cos x, and the value of y double dash, which is equal to minus a cos x minus b sin x. And now let us put these values in equation number 1. So we have the value of y double dash, which is minus a cos x minus b sin x, plus 3, the value of y dash, which is minus a sin x plus b cos x, plus 2, the value of y, which is a cos x plus b sin x, and this is equal to 20 sin x. Simplifying this equation, we get a plus 3b cos x plus minus 3a plus b sin x is equal to 20 sin x. Comparing the coefficient of cos x and sin x on both sides, we have a plus 3b is equal to 0 and minus 3a plus b is equal to 20. Now solving these two equations, we get the value of b, which is equal to 2, and the value of a, which is equal to minus 6. Putting these values in equation 2, we get the particular solution, which is equal to minus 6 cos x plus 2 sin x. And now the general solution, y is equal to yc plus yp. Putting values, we have c1 e power minus x plus c2 e power minus 2x minus 6 cos x plus 2 sin x, and that is the required solution of this problem. Case 3 is for different types of polynomial. If g of x is equal to c, which is a general constant, we shall put yp is equal to a. Let us see this example. If g of x is equal to 1, we will put yp is equal to a. If g of x is 1 over 2, 1 over 3, we shall put yp is equal to a. If g of x is equal to 2 or 3 or 4 and so on, any real number, we shall put yp is equal to a. If g of x is first degree polynomial, it means if g of x is equal to ax or ax plus b, we shall put yp is equal to ax plus capital B. Let us see this example. If g of x is equal to just x, put yp is equal to ax plus b. If g of x is equal to 2x or 3x or 4x plus 2 and so on, just put yp is equal to ax plus b. Second degree polynomial. If g of x is equal to ax square plus bx plus c, or g of x is equal to ax square, we shall put yp is equal to ax square plus bx plus c. Let us see an example. If g of x is equal to x square, use this substitution. If g of x is equal to 3x square or 4x square plus 2x plus 3, use yp is equal to ax square plus bx plus c, and so on. And so on mean if g of x is third degree polynomial, it means if g of x is equal to ax cube, we shall just generalize this thing and we will write yp is equal to ax cube plus bx square plus cx plus d, and so on. Question number 3. To solve equation 1 as usual, we need yc. Yc, the complementary function, is equal to c1 e power minus x plus c2 e power minus 2x, which we know from question number 1. And now we can see that 4x is first degree polynomial. So according to case number 3, yp is equal to ax plus b. Let us say this is equation number 2. From here we get y dash, which is equal to a, and y double dash, which is equal to 0. Putting these values in equation number 1, we get 0 plus 3a plus 2ax plus b is equal to 4x. From here, we can get 3a plus 2b plus 2ax is equal to 4x. Now, comparing the coefficient on both sides. On the left hand side, the constant term is 3a plus 2b, and on the right hand side we have 0. On the left hand side, the coefficient of x is 2a, and on the right hand side the coefficient of x is 4. Let us say this is equation number 3 and this one is 4. Now from 4 we can get the value of a, which is equal to 2, and from 3 we can put a is equal to 2, so we have 6 plus 2b is equal to 0, which gives b is equal to minus 3. Putting these two values in equation number 2, we get the required particular integral, which is equal to 2a minus 3. And now the general solution is y, which is equal to yc plus yp. Putting values, we have y is equal to c1 e power minus x plus c2 e power minus 2x plus 2a minus 3, and that is the required solution for this problem. Case number 4. If we have the product of polynomial and exponential function, let us see if g of x is equal to first order polynomial into e power alpha x. Alpha is some constant. We shall put yp is equal to ax plus b e power alpha x. So let us see this example. If g of x is equal to x e power 3x, we shall put yp is equal to ax plus b into e power 3x. Or if we have 4x e power 3x or x plus 2 e power 3x, we shall use the same substitution. If g of x is equal to second order polynomial n to e power alpha x, we shall put yp is equal to ax square plus bx plus c e power alpha x. Let us see this example. If g of x is equal to x square e power 5x, or 3x square e power 5x, or 2x square plus 3x plus 1 e power 5x, we shall put yp is equal to ax square plus bx plus c into e power 5x. So we can see that in all these cases, we are using the case of polynomial. So if there is a third order polynomial, we shall put yp is equal to ax cube plus bx square plus cx plus d into e power alpha x, and so on. Question number 4. To solve equation 1, the first task as usual is to find the complementary function yc, which is equal to c1 e power minus x plus c2 e power minus 2x. Now to find yp, we use case number 4 because the right hand side is a product of first order polynomial and exponential function. Therefore, yp is equal to ax plus b into e power 2x. Let us say this is equation number 2. From here we can obtain y dash, which can be obtained by using the product rule. So we get 2ax plus b into e power 2x plus a e power 2x. Differentiating again, we get y double dash, which is equal to 4 into ax plus b into e power 2x plus 2a e power 2x plus 2a e power 2x. And now substituting all these values in equation number 1, we have 4 into ax plus b e power 2x plus 4a e power 2x plus 3 into y dash. Y dash is 2 into ax plus b into e power 2x plus a e power 2x plus 2y, which is ax plus b into e power 2x, and this is equal to 36x e power 2x. Let us simplify this equation. So simplification will give us 12 ax e power 2x plus 7a plus 9b into e power 2x is equal to 36x e power 2x. Comparing the coefficient of x e power 2x and e power 2x, we have on the left hand side the coefficient of x e power 2x is 12a. And on the right hand side, the coefficient of x e power 2x is 36. If we simplify this, we get a is equal to 3. Now, comparing the coefficient of e power 2x, on the left hand side, we have 7a plus 9b. On the right hand side, we have 0. Putting a is equal to 3 here, we get 7 into 3 plus 9b equal to 0. This implies that 9b is equal to minus 21. And this gives us that b is equal to 20 minus 21 divided by 9. And we can write 3 3s are 9, 7 3s are 21. And now we have b is equal to minus 7 divided by 3. Therefore, yp becomes, putting values in equation 2, we have a, where a is 3, so we can write 3x plus b. b is minus 7 by 3 into e power 2x. Now the general solution is y is equal to yc plus yp. Putting values, we have y is equal to c1 e power minus x plus c2 e power minus 2x plus 3x minus 7 by 3 into e power 2x, and that is the required solution. Case number 5. If g of x is equal to sine bx e power x or cos bx e power x. In other words, if g of x is the product of sine and exponential function or cos and exponential function, then we shall put yp is equal to e power ax into a cos bx plus b sine bx. And now let us use this case to solve a problem y double dash plus 3y dash plus 2y is equal to 20 e power x into cos x. Let us say this is equation number 1. The complementary function yc is given by yc is equal to c1 e power minus x plus c2 e power minus 2x. And according to case number 5, yp is equal to e power x into a cos x plus b sine x. Let us say this is equation number 2. Yp can also be written as a e power x cos x plus b e power x sine x. And let us differentiate this y dash. We apply the product rule on the first term as well as the product rule on the second term. And after simplification, we get a plus b into e power x cos x plus minus a plus b e power x sine x. Let us differentiate this once again and obtain y double dash, which is equal to, again we can use the product rule on the first term as well as the product rule on the second term. And after simplification, we get 2b e power x cos x plus minus 2a e power x sine x. Now putting these values in equation 1, we get 2b e power x cos x minus 2a e power x sine x plus 3 y dash. Y dash is a plus b into e power x cos x plus minus a plus b e power x sine x plus 2y, and y is a e power x cos x plus b e power x sine x, which is equal to 20 e power x cos x. Now let us simplify this equation. So after simplification, we get 5a plus 5b into e power x cos x plus minus 5a plus 5b e power x sine x, which is equal to 20 e power x cos x. And now let us compare the coefficient. We have 5a plus 5b, which is equal to 20. This is equation number 3. And the coefficient of e power x sine x on the left hand side is minus 5a plus 5b, and on the right hand side it is 0. Now let us solve these two equations. So if I solve these two equations, I get 10b is equal to 20. And from here we get that b is equal to 2. Putting b is equal to 2 in 4, we have a is equal to 2. So using the value of a and b in equation number 2, we get the value of yp, which is equal to e power x 2 cos x plus 2 sine x. And now the general solution, let us obtain the general solution, which is y is equal to yc plus yp. And this can be written as y is equal to c1 e power minus x plus c2 e power minus 2x plus e power x into 2 cos x plus 2 sine x. And that is the required solution of the given problem. Case number 6. If we have the product of a polynomial with sine function or with cos function, then how to find yp for that problem? Let us see some particular cases. If g of x is equal to x sine bx or x cos bx, we shall put yp is equal to ax plus b cos bx plus cx plus d sine bx. By x here we mean if we have any first degree polynomial, x may be 2x, 3x or 2x plus 1. For any first degree polynomial multiplied with sine bx or with cos bx, we shall use this substitution. Now let us see if g of x is the product of a second degree polynomial, x square sine bx or x square cos bx. Then we shall put yp is equal to a1 x square plus b1 x plus c1 cos bx plus a2 x square plus b2 x plus c2 sine bx. By x square we mean any quadratic equation, any polynomial, just like we can use ax square plus bx plus c. Still we shall use the same substitution and so on. Question number 6. To solve this problem, let us find its auxiliary equation, which is d square minus 1 equal to 0. And if we factorize this, we have two roots, plus 1 and minus 1. So yc for this equation is given by c1 e power x plus c2 e power minus x. Now let us find yp by using case number 6. So according to that case, we have ax plus b cos x plus cx plus d sine x. Let us say this is our equation number 2. Now let us differentiate this. So y dash p is given by minus a x sine x plus c x cos x plus a plus d cos x plus minus b plus c into sine x. And now let us find y double dash from this one. So differentiating once again, and if we simplify, we get minus a x cos x minus c x sine x plus minus 2a minus d into sine x plus minus b plus 2c into cos x. And now let us put all these values in equation number 1. So equation number 1 becomes, we put all values, we have minus a x cos x minus c x sine x plus minus 2a plus d into sine x plus minus b plus 2c into cos x minus y. Let us put the value of y. So y is ax plus b into cos x plus cx plus d into sine x and this is equal to 2x cos x. If we simplify this equation, we have minus 2a x cos x minus 2c x sin x plus minus 2b plus 2c cos x plus minus 2a minus 2d into sin x, and this is equal to 2x cos x. Now comparing the coefficient, we have, first we compare the coefficient of x cos x on both sides. So we have minus 2a is equal to 2, and from this we get the value of a, which is equal to minus 1. Now we compare the coefficient of x sin x on both sides, and we have minus 2c is equal to 0. This will give us c is equal to 0. And now we compare the coefficient of cos x on both sides. So we have minus 2b plus 2c is equal to 0. But c is 0, therefore we get b is equal to 0. And now we compare the coefficient of sin x on both sides. So we get minus 2a minus 2d is equal to 0. And if we put the value of a, this give us d is equal to 1. So using all these values in 2, we get the particular solution as follows. 2 implies that yp is equal to, the value of a is minus 1, so minus x, b is 0, plus 0 into cos x, plus c is 0, d is 1 into sin x. So we get minus x cos x plus sin x. And now the general solution, y is equal to yc plus yp. Putting values, we have y is equal to c1 e power x plus c2 e power minus x cos x plus sin x. And that is the required solution for this problem. The last case, case number 7. If we have the product of exponential function, polynomial, and sine or cos, then how to solve that problem? Let us see it. If g of x is equal to e power x into x sine bx or e power x into x cos bx, we will put yp is equal to e power x into ax plus b cos bx plus cx plus d sin bx. Here by x we mean any first degree polynomial. So it may be 2x, 3x, 4x, or x plus 1, x plus 2. So if it is any first degree polynomial, we shall use that substitution. And now if g of x is equal to e power ax into x square sine bx or e power ax x square cos bx, in that case we shall put yp is equal to e power x into a1x square plus b1x plus c1 cos bx plus a2x square plus b2x plus c2 sin bx, and so on. By x square we mean second degree polynomial. It may be any quadratic equation. So we shall use that substitution. Let us see an important note. In all cases which we have studied, if we find yc and then we use the substitution of yp, and if we see that there is a common term in yc and yp, we shall multiply yp with x. And if we again see the common term, then multiply with another x. And if we again see a common term, then multiply with another x, so that there will be no common term in yp and yc. Let us explain it by some examples. To explain this note, let us solve question number 7. To solve equation 1, the first task is to find yc, for which we need its auxiliary equation. So its auxiliary equation is d square minus 6d plus 5 equal to 0. And now let us factorize this. So if we factorize, we have d minus 1 into d minus 5 equal to 0. And from here we get two roots. D is equal to 1 and d is equal to 5. So yc is equal to c1 e power x plus c2 e power 5x. And now let us find yp. So the typical yp according to case number 1 for this problem is a e power x. But we can see that a e power x is common with c1 e power x. Just look at the function of x here. We have e power x in yp and we also have e power x in yc. So these are two common terms. So multiply yp with x, which will give us ax e power x. So now this one is our required yp, but the above yp is not correct. So now differentiate this. Y dash p is equal to a x e power x plus a e power x. Let us differentiate it once again. We have ax e power x plus a e power x and plus a e power x. Let us put these values in equation number 1. So we have y double dash, the value of y double dash is a x e power x plus 2a e power x minus 6, the value of y dash, which is equal to a x e power x plus a e power x plus 5 y. The value of y is ax e power x, and this is equal to 8 e power x. And now let us simplify this equation. So if we simplify this equation, we have, from here we have 6ax e power x. This is ax plus e power x and this is 5. So these terms will cancel. So what we have 2a e power x and minus 6a e power x, which is equal to 8 e power x. From here we can get minus 4a e power x is equal to 8 e power x. Now let us compare the coefficient on both sides. On the left hand side, the coefficient of e power x is minus 4a. On the right hand side, the coefficient of e power x is 8. So from here we get that a is equal to minus 2. So putting this value in 2, we get the particular solution. So the particular solution for this problem is yp, which is equal to minus 2x e power x. That is the required particular solution. And now the general solution y is equal to yc plus yp. Putting values, we have yc is c1 e power x plus c2 e power 5x, and yp is minus 2x e power x. That is the required solution for this problem. Now let us explain this notes a little more. In this example, or in this question, we saw that yc was c1 e power x plus c2 e power 5x. That is why the typical yp is equal to a power, yp is equal to a e power x is not a correct yp because these terms are common. So yp was equal to ax e power x. That is the correct yp for this problem. Now here I have to explain a little more. If we have some question in which yc is c1 e power x plus c2 e power 5x plus c3x e power x, then just like in this typical situation, yp will be equal to a e power x. But as this term is common with this one, so we must multiply this with x and we get yp is equal to ax e power x. But again, we can see that this term is now common with this one. So what we have to do? We have to multiply again with x. So we get yp is equal to ax square e power x. So now this yp is wrong, this yp is wrong for the above question. The correct yp is this one, and so on. That's all. I hope this lecture will be helpful.